Hello and welcome back to part 9 of my algorithms video tutorial series. In the last one we covered the bubble sort, which is one of the slowest algorithms that you can get. In this one we're going to cover the selection sort. The selection sort is probably one of the most intuitive ones, but if we want to sort the algorithm, the list in place, rather than create a new list, it's slightly more complicated than it might seem. One of the difficult things is something that we've already tackled with the bubble sort, which is actually swapping values. If I play this visualization of the selection sort algorithm, this is from visualgo.net, and we'll talk about exactly what's happening before we do this. So what it's doing is it's looking for the lowest number. So it'll go through the list from a certain point looking for the lowest number. When it knows the index of the lowest number, it will swap it. But then it moves up to the next one. We know we don't need to swap this one again, this 16 again, because that was the lowest one. So each time we're going to go up, we're actually going up one less. So we're sorting one less in the list each time we're doing that. And then as we go up, all we really need to know is what the index is of the next lowest number, not the lowest number overall, but the next lowest number. And then you just swap that next lowest number to the next point that you're working on in that list. It's a little bit confusing, so take some time to maybe watch this visualization, or perhaps to go back to the CS field guide and try and apply this type of algorithm, the selection sort algorithm, for yourself, so that you can get a better idea of how it works. You can see that it is slightly more optimized in the bubble sort, because as you're going up, you're needing to sort one less each time, because the ones that you've already decided are found out that they are the lowest values. You don't need to sort them anymore, so you can actually sort slightly less. So it is slightly faster than the bubble sort. So first up, let's clean up the code from the last time. I'm not going to need the bubble sort from the utilities method. I'm also gonna not capture the time. I showed you that in the last video, just in case that was something that you wanted to look at. I'm gonna replace this line right here with my own sort, but we need to write that first. And let's just get rid of the time again. So I do want to print out this, but I'm gonna do that a little bit later on. So we'll get rid of it. So we're keeping it really simple. We're gonna get a random list. I may just do 10 for now, just because we want to make it nice and simple, and we want to be able to see that the results have worked correctly. I'm going to print out that list. Then I'm going to do my bubble sort, my selection sort, and then I'm going to print that list. So let's write that selection sort. Oh, I can get rid of time too. I'm not going to need that for now. So let's write that selection sort function. So I'm going to call it selection sort, and all it's going to take in is a list of the data that you'd like to sort. And like before, we're going to do this in place. I'm really not sure what the easiest way to explain this is, or to do this. So what I might do is just do the inner loop first. So what I'm going to do is I'm going to create or initialize the index of the lowest to 0. So we need to do this more than once, but this inner loop might be the easiest one to kind of explain, and then we can adapt it so that we can go again over at the next one up. So it's not 0 but 1. So I'll do the inner loop just to check that it actually works. So what I want to do is I want to be able to loop through everything in the everything inside that list to find the lowest, the index of that lowest. Currently we've set this to 0. We're going to go through the whole thing. So I'm going to start at the index 0, and I'm going to go to the length of the data. So I'm going to go through absolutely every single piece of data to find if it's the lowest. So if it's lowest, we want to store the index of the lowest value. So we'll just do the comparison. So if the data that we're looking at, the current data that we're looking at, is less than the value that is at the current index of lowest, then we know that we've found a lower value. So we'll just set this index of lowest to be I, to be the current index that we're looking at. Have a good think about that. It doesn't make sense if you think about it. And then once we've exited the for loop, so when we've gone through absolutely everything, we swap the lowest value, whatever that happens to be, to the front of the list, to the index that we're looking at. So just for now, it'll be I'll put in front inside of quote marks, because it'll be the front, but not always the front. It'll be the one that we're currently looking at. To do that swap, we've done swaps in the bubble sort before, so we do this multiple assignment thing where we say that index of lowest, so data comma in data index of lowest is equal to, and then we're basically swapping them around. So we'll say index of lowest comma data C. So that will just it's actually 0. Yeah. So there we go. So because we're looking at item 0, we should be able to go through the entire list. We look to see what as we go up the indices, we'll look to see if it's the value that it holds is less than the current value that's held. And then if it is, we find out what that index is, and then we basically swap them. So whatever it is should be swapped. So no matter what list I have, if we run this through once, what we'll say is we'll do our selection sort, and we'll pass in my list, just like we did before. What we should see is that the list will print twice. So let's just run this. When we run this, we should see that it prints out the list twice. So the first random list looked like this one. It used index 0 here. It was looking for a lower value, so it went all the way up the list. 6 would have been lower, and then 3 would have been lower still, and then 2 would have been lower still, and then 7 wouldn't have been, but 0 would have been when it got to the very end. 0, the index, it would be 0, 1, 2, 3, 4, 5. Index 5 would have been the lowest, so it swapped index 5 with the current index 0, so it just swapped those values. So you see that the 8 ended up here, where the 0 was, and the 0 ended up at the beginning. So that inner loop part works, but obviously we need to go up 1 now. So not index 0 anymore, because we know that that's sorted. We need to go up 1. So we'll just implement that in the code now. So I kind of gave the game away a little bit earlier when I accidentally typed in C for data here. So I'm gonna create a for loop, and I'm gonna say for C in range length of data again. So we're gonna go up the indices. Just select that, highlight that. So I've moved it over. Oh, it looks weird because it's word wrapped. So C now starts off at 0. So instead of using the value 0, we're going to use the value C. That's also why in this range statement, we can actually start a range statement not from 0, if we put a number and then a comma and then the end. So this is the start index and that's the end index, or that's the start of the range and the end of the range. So if I say C now, then the next time this for C in range works, C will be 1. So it'll start at 1 and go to the end. And then the next time will be 2 and go to the end, and then 3 and go to the end, which is exactly what you saw in the visualization. The last important point is obviously we want to swap the correct one. So we need to use the index of C wherever we're currently started our range search. That's the one that we want to swap. So we need to swap over here as well. So we'll swap them over. So let's just quickly test that too. So as you can see, our selection sort kind of works. It's managed to sort the list of 10 without any difficulty and no errors. So it looks like the selection sort works. The next step would be to work out how many iterations or how efficient this algorithm is. So again, one of the key things that we can do, one of the easiest things we can do is create a variable that just counts the inner loop, so it counts the iterations. So the inner loop is this one that we wrote earlier on. All we'll do is we'll say count plus equals 1, so we'll add 1 onto count, and then because we're searching, sorting this in place, we don't need to return anything else, so we could actually just return the count to see how many times this actually iterated in order to completely finish the sort. So I'll just say result equals, and then we'll just print the final list, and we'll also print with an F string, this took, and we'll say result comparisons. So with 10 items, if we run this, this took 55 comparisons. So your job is to work out if how that compares to the other sorting algorithm. So we have the selection sort, but we've also got the bubble sort, and one is slightly better than the other. And also, your job is to try and create a graph. A CSV would be good, with significantly more data than a single search. So you might do a graph with 10, and then one with 20, and then one with 30, and one with 40, and one with 50, so that you can graph and see what happens to the efficiency of the algorithm as the size of the data increases. Just as a quick check, if I went to 20 and run this, you'll see that we've got 210. If I went to 30 and run it again, I'm assuming it's still working. I could quickly check. Yep, so it's working. That's 465. And then if I went to 40, you should start to see the fact that this is not a linear increase in the efficiency of the algorithm. So it's not like if you double it, you get twice as many, it's more. And your job is to be able to explain that and be able to make a graph that shows that allows you to better explain that. So as before, I added in my useful comment that tells the user of this function what it takes in and what it returns and what it does. And then we're going to just biff it out, so Control exit and put it into my utilities. Always leaving a couple of spaces at least between each of the functions so that it's a lot more readable. Now back into main.py, we want to return, import get random list, and we also want to use selection sort, so that this should work exactly as before, just a couple of spaces again between each of the bits of code. And if we run this, we see it gets the sorted algorithm, and it tells me how many comparisons. So that's pretty much it for the selection sort. As I said before, your job is to try and work out or be able to create graphs to compare them and be able to explain why they do what they do as the size of this list increases.